So that's that connectivity to energy-specific applications and data stores. So we have various places and locations that are unique to us. Being able to master specific data types like wells, well bores, and well components. Having those default business rules. So those business models, whether that's PPDM, where it's configured to specific company requirements, policies, and standards. As time's moving forward, and we have the onset of OSD to move and migrate data in and out efficiently. And then what's being able to manage your data without being able to visualize it. So having those specific energy visualization tools with regards to logs, seismics, and tops. So there you have a kind of two-tiered approach to data management, building on your core capabilities within industry specific. So that's just a brief history of where we've come from with regards to our approach to data management. But going back to the topic that we had at the start. So obviously we have large-scale digitization projects that occur within any large organization or government that has been going for an extended period of time. We need to do these digitization products, and with that, periodically we need to do database cleanups and data management and implement data management solutions. But over the last number of years, we see this as being quite a cyclical event. So that happens around every 10 to 20 years that we need to be doing some form of digitization project and some database cleanup. But how can we kind of break this link? It's something that we've never been able to do. We seem to put management systems in place, accumulate data, and then need to go back and digitize. And the way that we see it and our approach is that if you manage your data properly, you break the gap between accumulating data and then having to digitize it, because you're no longer just archiving off the information that you're accumulating. You're actually managing that data we're in, and then you don't need to continually do the digitize efforts. And if we're implementing a long-term data management strategy and future-proofing it, then it allows us to stop having to do that constant database cleanups. So we see that link between digitization and data management that we've seen over a number of decades being able to be solved by doing a consistent, holistic, enterprise-wide approach to data management. So how are we going to do that? Again, if we take a step back, this year S&P commissioned a white paper exploring the geoscience data management landscape from a global user base. The findings and the results of this confirm what many of us already know, and that we get results broken down into three main areas. That ultimately G&G community and G&G staff is having 70% is getting data available in a timely manner. So that's to do with data access and sharing. Next is data integrity, so complete data and accurate data. And then third, it's that data lineage of being able to discover and getting that granular detail that you need. So it's still the same old adage: I can't find it, I don't know what I've got, it isn't complete, and I'm not getting it quick enough. So we're seeing, as a result of this white paper, that up to 80% of a geoscientist's time is still spent managing, preparing, searching data to find what they actually want, which is not a good resource. It's not a good utilization of their time. So that needs to be improved. Reasons why this happens and reasons why this could be, we seem to get into this position periodically, is that we have old-fashioned silos. So most upstream companies, including national governments, have different groups that access the same data day to day. So we have the exploration groups, the asset groups, reservoir engineering, and now with the onset of more CCUS and environmental stuff, those groups now accessing the same data, because the same wells, the same directional digital logs, all of that information is useful to all of these groups. So we're all pulling on that information. when we break that down even further, we're seeing that's made even more complex by the array of subsurface applications that we need, because those groups use, quite rightly, specific tooling to optimize what they can do. So for instance, if we have a Petrel instance, we have multiple instances, multiple projects within that Petrel environment. And so that contains all of those well headers, all of that information that we saw on that last slide. But that's one group. Another group may be using Kingdom. And again, we have those individual projects all mapped out to different areas, different locations that are all pulling on that same data. So we can see similar data mirrored across different projects between two applications. But then we start to expand that out into, say, Petrel Studio, OpenWorks. Then we really start to get a network and a spider web of all of this information that is being pushed and pulled, that same information across the organization. And that white paper that I mentioned earlier, we see that more than 50% of respondents were using more than 11 applications utilizing this same data. So when we start to populate a few more of the industry standard locations, network paths, systems that are actually using that same data, we can start to see that a data manager's time, or an end user, we can quickly see how their time is built up on managing that data. And that leads to various duplication, and we start to see how from that original diagram of the recycling between data management, accumulating data, and then doing digitization efforts, we can start to see how that spirals out of control, and justifiably how we've kind of continued to go down that road, even with advances in all of our digital technology. So how can we solve that? We need to have a unified, democratized data management structure. So with that, we've got we've got a democratized discoverable. Sorry, if we take all of those core principles of what we want a system to be, we can plot this out in the middle. So we want our data and information to be democratized and discoverable. We want every user who can access, permission-based obviously, to have access to that data as and when they need it. Governance, we need that governance layer that applies all the principles of the organization and the workflows around that baked into the data management system. We need industry templates, both reading in and publishing out to industry, how that information is consumed and made available to the wider community. A very key important thing is having plugins, APIs, SDKs, and direct connectors to where data lives. Our data management function shouldn't have to have all of the information residing in one location, sitting over the top of it. It should be able to connect to where that data lives and breathes. A matching engine, so we can create that unified gold standard based on those locations of where the data lives, and allow the organization and industry as a whole to consume the most relevant and the gold standard data. We need it to be configurable. It can't be a black box that just does one thing and then is sporadically updated. It needs to have the functionality to evolve with the business rules and the workflows of the organization to be able to keep it living and breathing. Exception management. We need to be able to automatically detect rogue data, errors within the system, to be able for data managers to be able to update and make sure that we've got the optimized system and find bad data and inaccurate data, which we saw at the start was one of those drivers. It needs to be integrated, have integrated security. So for instance, here we've got an SSO, a single sign-on, to bring down barriers of entry into the system. So it's not like another piece of software that needs to have login details, that needs to have other credentials. It needs to be able to be utilized very, very quickly and easily. Again, with that governance. We need validation and business rules set up that work for the organization and the industry as a whole that are baked into the system. Automation. We need to make as much of this automated as possible, optional, to be able to assist and speed up deployment, to speed up access to data, and keep it as optimized as possible. Because sometimes with systems that are more manual, they're deployed and they're working well, but when they get overloaded with new data and new information, it can quickly start to get that backlog. Rec and sync. It needs to be able to dynamically go across the application landscape and the data landscape and move and reconcile data and synchronize it and back publish it to update and override and master the data back to where it came from. So how does that look when we start adding those data streams into the system? So that's what our data management solution looks like. But we want to bring in the information that we have. So we have various data subscriptions, various geoscience applications, production data, that GIS information, the core data from our data lakes, data warehouses, and then when we start well planning and things like that, we have various financial systems like SAP, etc. So we want all of those sources to come into this data management system. And then we want that information to be pushed out to industry as a whole. If we're applying this as a national data repository type environment, or back out into the organization where it can be consumed by geoscience applications, Power BI dashboards, various other consumptions that the wider community use day to day, but let's make as much as that as possible. You'll see here that all the arrows are bi-directional. So on the left, we have our GG&E applications. They're also on the right-hand side. So it's not just about pushing from the left to the right. It's bi-directional. It's circular, so data moves around the system rather than going just on a one track path. So when we take that enterprise approach, applying those data management principles, we take that original spider web that we saw earlier in the presentation, and rather than being a data manager sitting in the middle of this web and moving, migrating data, keeping track of all that information, when we apply a that enterprise approach, we see a lot of that can be automated. We have that bi-directional flow of data that can all be monitored and maintained by the system and automate as much as possible. So in summary, by applying an enterprise approach and core principles of data management, we can create a system that will live dynamically within the organization and move with the times to reduce the constant requirement for periodic digitization and data management and data cleanup efforts. This approach allows G&G professionals more time to focus on that value add part of their job rather than the time consuming data, finding and wrangling obstacles. So thank you for your time. My email's on here if you want to reach out to me. As I mentioned during the talk, the white paper that we commissioned, there's a QR code if you would like to scan that to have access to it. Please feel free. It'll give you an option to download it. But from there, if anybody has any questions or if I haven't overrun, thank you for your time.
Thank you very much, Mr. Craig, for your wonderful presentation. We don't have here any questions. I believe you made a very clear presentation. We just need to thank you so much. And then we're going to pass to the next presentation. Thank you very much, Mr. Craig.
Thank you.
Okay?
Hi, good afternoon.
Good afternoon,
Yeah,
Mr.
now we
Kirill. Can you hear me clearly?
Yeah, I can hear you. And you?
Thank you so much for being here. Can you share your screen and start your presentation? I'll present you.
Okay, yeah, sure. Share my screen. Okay, so I think you now should see my screen.
Yes, thank you. Hello, everyone. We have now Mr. Kirill Sirayev talking about overcome the challenge of limited well data, rock physics, and AI-based reservoir characterization. Mr. Kirill, please be our guest. Thank you.
Yeah, thanks for introduction. So, as it said, so my presentation is about how to overcome the challenge of limited well data, and we can do it using this rock physics and AI-based reservoir characterization approach. And I would like to start my this presentation with answering on a general question, very general question: why should we use this machine learning in seismic interpretation at all? And let's say the answer to that question lies in the most common challenges we faced with when conducting reservoir characterization. And first of them, it's always limited well control. So when we have a few wells available, it's very difficult to get reliable results in the interval space. And machine learning could easily solve this challenge by using pseudo wells for training. So we can generate pseudo wells, then use them to train neural network, and then apply this trained neural network to real data, to real seismic data. So basically, my today's talk is about this approach. And using this approach, some other challenges can also be solved. So, for example, thin bed detection, so and complex geology, so that's always challenge. And this approach, I mean, rock physics-based machine learning, allows us to identify thin bodies and work with fields with complex geology. Of course, let's say the main and the most common reservoir characterization method is seismic inversion, and many of inversion algorithms rely on different assumptions, which can be simply violated. So machine learning algorithms don't rely on any assumptions. Again, if we're talking about seismic inversion, many of inversion algorithms use two-step approach for reservoir properties prediction, and this is some kind of error accumulation. And using machine learning, we can do direct prediction of reservoir properties. And it's not so time-consuming as seismic inversion, and it allows us definitely to speed up reservoir characterization due to many of reasons I will talk to you about later. So there are too many different machine learning techniques, machine learning algorithms, and the most powerful deep learning techniques. And here on this graph, I'm showing deep learning benefits from extensive amount of data. So it's quite clear from this graph, but the more data we have, the more data we use, the better performance we have. So performance here means the accuracy of prediction. And the question is, if we have only a few wells available, if we have only one well, how can we increase this amount of data? Where can we take this additional data? And the answer is generate them. So yes, answer and proposed solution is generate this data. So this is happening based on rock physics modeling, synthetic catalog generation, and convolutional neural network. Let's now consider a workflow. So here's the workflow. It is separated on two big stages. Let's say stages. First stage is the left part of this slide. It's synthetic catalog generation, and second part is convolutional neural network applying. So let's quickly consider this workflow step by step. And as usual, we start with this petrophysical analysis. So here we do basic well data preparations, basic conditioning steps, and so on. Required input data are at least one well. And this well should contain curves what you need to establish a rock physics model suitable for your reservoir. And the list of curves, it's depends on the rock physics model you use. So next step after petrophysical analysis, it's little layer classification. Here we break our real wells into a series of little layers. We can do this based on different thresholds of input curves. For example, here I set 2 classes for water saturation based on water saturation curve, then 3 classes based on clay volume curve, and 2 classes again based on porosity curve. And these red lines here on this middle visualization area, these are our thresholds. And finally, after this step, we have little layers or facies log. If you have your own lithology curves here on this step, you can simply use them. So skip this step and move on. Move on to next step, which is rock physics modeling step. Basically, this is one of the most important steps in the workflow. The goal here is to establish rock physics model, linking elastic parameters to rock properties, and then calibrate this model on your data to get reliable predictions later. So orange curves on this view are conditioned curves from well data, and blue curves, all these 6 blue curves, are estimated curves which we obtained using rock physics model. So we see we have very good match between curve for P wave and for density. That means that our model is calibrated and we can move on to the next step. And the next step is statistical analysis step. So as you remember, on the step number 2, on the little layer classification step, we obtained little layer log. And now on this little layer statistics step, we need to establish statistics for each of those little layers. This statistic is characterized by multivariate Gaussian distribution and parameterized in terms of its mean and covariance. So background trend and covariance metrics calculated for each of these layers. We can QC these trends calculated for petrophysical properties corresponding residual curves, so that is curves after trend component extraction. And ideally, here on this plot, we should see some values around 0. And also we can QC these trends calculated for elastic curves as well. We also need to account for the fact that our well logs are vertically correlated, so this correlation is measured using variogram. And here, so we have options to model these variograms based on our input curves, input well data. And then when we have these well statistics and rock physics, we use it for pseudo well simulations. So the next step in the workflow is pseudo well simulation step. Firstly, on this step, we simulate petrophysical properties, and then from these simulated petrophysical properties, we calculate elastic parameters using calibrated rock physics model. So to QC these simulation results, we can apply different techniques here. For example, we can generate series of Gaussian visualizations, how it's shown here. Here showing 10 different Gaussian realizations. What else we can do? These simulations can be superimposed to what-if scenarios, applying to specific layers to generate training examples spanning a range of expected geology. So we can set variations of porosity, thickness, water saturation, and so on. And on this step, we can simulate as many pseudo wells as we want. So it could be even thousands of wells, but usually 300 or 500 of wells, it's sufficient to describe all scenarios that we have in the geology. So when we have these elastic logs, elastic pseudo well logs simulated, we can use them to generate corresponding synthetic seismic gathers. So the next step of the workflow is synthetic modeling. These synthetic seismic gathers could be generated using different techniques, for example, using Soplitz equations and wavelet extracted from real seismic data. So on a previous step, for example, I simulated 150 pseudo wells, and on this step, I generate corresponding number of synthetic seismic gathers. So this is the final point of this synthetic catalog generation stage. And now, at the moment, we have this synthetic catalog, large synthetic catalog consisting of pseudo-wells and corresponding synthetic seismic data. And what we can do next, we can use this synthetic catalog to train convolutional neural network and obtain some operator, which is shown here as a brain. In this operator will be trained only on this synthetic data. It will not include real well and real seismic data for training step. And we can use, generally this CNN approach, convolutional neural networks are used in image classification, so to classify different objects on your picture to different classes. And as we're talking about seismic data, what difference or even benefit of CNN usage, what it could be applied directly to seismic gatherers. So it recognizes seismic gatherers as these images, and CNN can predict several target properties simultaneously at a time. So we, as I said, we have prepared this large synthetic catalog, synthetic database, and now we train. Here on the left, you can see the workflow, and the first step is training, where we train convolutional neural network on this synthetic data. So input data here are pseudo-wells and synthetic seismic gatherers. So here, as you can see, I do prediction of 5 different target properties at a time. So P impedance, S impedance, density, porosity, and water saturation. So any target property could be used as a target. Reservoir in this example is located right here at this zone. And about parameters, it's very simple to parameterize. So most important parameters here are number of iterations and number of hidden nodes. And to find the optimal number of these parameters, we use this validation plot. So here you can see 2 lines, blue and orange lines. So blue line here is training, training error, and the orange is validation error. So I used just 50 iterations here, and you see that both these curves are still decreasing. So we can increase number of iterations to get better results. So we can QC results using different approach. So for example, we can do it firstly visually. We can take a look on different statistical measurements like correlation coefficients or different kind of errors. And after this step, after CNN training step, we have CNN operator, which is trained fully on synthetic data, on pseudo-wells and synthetic seismic gatherers. And now we can apply this operator to real data at real well location. So and using this applying on real well locations, we can see the quality of this CNN convolutional neural network operator. So the goal of this step, applying at well location, is to evaluate these CNN parameters at well location, at real well location. And here you can see a result after this applying. And we need to again to QC these results. Again, we have the same QC options here. So generally results after this step is already might be acceptable. But so far, as I said, we used only synthetic data to train this network. And the process called transfer learning, so this is the next step in our workflow, transfer learning step, gives us ability to incorporate our real seismic data and, let's say, update this operator to enhance the result of predictions. So here you can see prediction results after this transfer learning step. So we had some operator trained on synthetic data, then we incorporated real seismic data and updated this operator. And here results of applying this CNN at real well location, and we see but these results becomes much better. So let's compare them with the previous one, with previous results before this transfer learning step. So pay your attention at this reservoir zone. So this is after transfer learning, and I don't know if you have a delay. And here you can see results without this transfer learning step. Again, after transfer learning and before transfer learning, so it's definitely became better. So generally, this transfer learning process, transfer learning step gives us many different benefits. Just an example, if you work on some project you created with rock physics model, you generated synthetic catalog of pseudo-wells and synthetic seismic gatherers. When you trained neural network on synthetic data, get some prediction results, and then let's assume that after some time you receive new seismic data close to the previous area. So the benefit is the absolute seismic data on this transfer learning step and get results, let's say by clicking just one button. So that's just amazing. So let's now back to the workflow. We have updated this CNN operator by incorporating of real seismic data, and now we can apply it to the whole volume. And finally, after this step, we have volumes of target properties as results, for example, volumes of P impedance, porosity, and water saturation. So we know that any property could be used as a target. It depends on rock physics model you use at the very beginning, at the very first step. So of course, it's always very important to estimate uncertainty of final results, and we can do it right here. So the last step in this workflow is uncertainty analysis. So in fact, uncertainty analysis in machine learning is crucial for several reasons. Firstly, it helps us to establish confidence in machine learning predictions for identifying optimal drilling locations. Then uncertainty quantification provides a more comprehensive view of model predictions. So it helps us to judge model reliability, data reliability, model selection and validation. And assessing model prediction reliability and confidence in noisy and uncertain data scenarios provides valuable insights into prediction spread and confidence levels. Now, just a few words how it works. So let me explain this methodology with using this example. So this is unconventional Barnett shell example. Here we applied this algorithm to predict volume of quartz. So within unconventional reservoirs, accurate volume of quartz estimation acts as very important indicator of brittle fractable rocks and potential drilling success. And to quantify this uncertainty in the predictions, following workflow was used. So it's a jackknife validation technique. It was applied to trained convolutional neural network, and by systematically omitting individual wells, multiple CNN versions generated, each representing a unique model variant. This process creates an ensemble of CNN operators equal to the total number of wells. So in this example, we had 7 real wells. That means we could create 7 different variations of CNN at certain CDP location. We can also calculate mean and standard deviation of these predictions to offer insights into the model overall performance and its variability across different well training data. So all this can be visualized through variability gathers volume shown here on the right. Yeah, on the slide. Sorry. Yeah, on the right part. So for each of these CDP, we have several variations. So as many variations, as many real wells we have. At least for this approach, at least we need to have 3 real wells. We can also visualize standard deviations volumes. So this is a standard. Here you can see standard deviation of quartz volume, and highlighted area using this black box reflects larger standard deviation, indicating high variability in models prediction and lower confidence. So this analysis illustrates both model robustness and possible areas of uncertainty. Let's now consider just one quickly consider one case study what we performed, what we done using this workflow, rock physics based machine learning. So this is reservoir property prediction using synthetic data catalog and deep neural network in West Trial Rockfield in Australia. Here's the summary, so let's now review it one by one. Western Rock gas field is located at western margin of the Barrow subbasin of the Carnarvon Basin of Western Australia, and hydrocarbon-bearing zone of these Western rocks is situated approximately at 3,200 meters below the seabed, with water depth of around 150 meters. Again, we deal with complex geology, which is described here, so in these 3 bullets. And for comprehensive understanding of the area's geology, we can suggest you to use this publication by MEF and BIRD. So the shales here, the most important point, what the shales here, the shales here are believed to be the primary source of hydrocarbons and possess good porosity and permeability. A few words about data availability. So we had pre-stack gatherers as input data, maximum angle of 38 degrees, and this is classic environment with 2 drilled wells exhibiting the class 3 anomaly response. So with stacked seismic data, which you see here on this slide, shows strong and bright amplitudes, highlighting different sand deposits in the area, and there are 4 main sand types: M sand, N sand, O sand, and T sand. And this M upper one, M sand, is the primary gas saturated reservoir and is found in both of these wells. So, as I mentioned, 2 wells were available in the area with basic petrophysical interpreted logs such as porosity, water saturation, and volume of clay, along with all these elastic curves. And this well 4A were used in the training of neural network, and another well number 2, were used for validation as a blind well. So the average thickness of sands in this area is around 40 meters. Based on this workflow, using this workflow, we created rock physics model and finally generated this synthetic catalog consisting of pseudo wells. And for this case study, we generated 225 pseudo wells, and then generated these pseudo synthetic seismic gathers. So you can see here these synthetic seismic gathers, also 225 different synthetic seismic gathers. The next 2 steps in the workflow, as you remember, is scene and training and transfer learning. In this study, 4 different properties have been predicted simultaneously: P-impedance, porosity, water saturation, and volume of clay. And here you can see results after transfer learning step at location of this well 4A. So the blue curves here are real measured curved curves, orange curves is predicted curves, and green is low frequency model. And you can see here what is really very good match with measured curves and predicted curves, and we can do quantitative analysis by looking on at the values of correlation and normalized mean square error. So we also have some other measures in this tool as well. So here is in this table is the summary of this prediction for well 4A, and pay your attention to first and third column, which correspond to results before transfer learning steps, and second and fourth columns corresponds to the results after transfer learning. And we see after this transfer learning step, we have significant improvements everywhere. So, for example, pay attention especially to water saturation prediction. So the initial model showed very poor match. It was about 15%, and after transfer learning, it became 93%. Here is the results of prediction in clay volume view, section of clay volume, and we see really good match even at this blind well location. So spatial continuity of events, it's also very good, even at location, again, not of this blind well. Similar estimation for porosity results in the section view. So we again have quite excellent match at well location and good continuity. So M, N, and O layers have very good porosity values. Here is estimation of water saturation. So again, we have very, very good match. And we also compared results of this approach to traditional methods, I mean to pre-stack conversion. So here is P impedance comparison, and it's observed that acoustic impedance from this CNN approach is stable. It's more stable with better continuity of fields of different bodies, and it's noise-free compared to results of pre-stack seismic conversion, shown here on the top image. Here is the same comparison, but for density. So just a reminder, we had angles up to 38 degrees in the gathers, and with pre-stack conversion, it's, as you know, it's always challenged to get reliable density predictions. We need to have at least angles at least up to 45 degrees, and that's why there is an obvious again improvement in density estimation using CNN approach, as observed here on this image at the bottom of the slide. And CNN predictions are better in terms of continuity, stability, and resolution. And these sandbags predicted by the CNN exhibit better continuity and a stronger match at blind wells compared to density prediction using pre-stack inversion. Just a few slides before the end, let's look on the results in terms of maps. So we generate the seismic root mean square amplitudes maps, and we can clearly see here two geological patterns. The bottom one, bright amplitude, is zone where we have these two drilled wells, as you see. But how about, the question was, how about this upper section? Does it really correspond to hydrocarbon or not? What's happening in terms of porosity here? And here is a map of clay volume. So here we can see we have high clay values at well location here. However, this upper zone has various variation from low to high clay percentage. When we look onto corresponding porosity maps, porosity doesn't confirm that we have high porosity in this zone, even if we have bright anomaly amplitudes here, if we're looking on the seismic data. So it's even more noticeable on the water saturation prediction. So we clearly see what this top zone is not filled with hydrocarbons. So whatever the interpretation is seen on seismic data, it's not observed on other volumes. This means that it's very important to perform such analysis on the early exploration stages. And the same can be shown on the net pay estimation. So previous maps were created for M sand layer, and here net pays are calculated for M sand and O sand layers. The cutoff zone is not filled with hydrocarbon intervals. So whatever the interpretation duration below seismic data, 80%, effective porosity above 10%, and clay volume below 45%. And here is the summary table of net base comparison. So from wells in blue color and from CNN in orange, in orange color. And we see that prediction by CNN, by this rock physics guided machine learning approach, is
about what Microsoft is all about in the world of energy, in support with the Account team. The agenda is very simple, as you've just seen. And these sharing a couple of ideas about what we are seeing in the trends and challenges that the industry is facing today, and then going deeper into our approach of investment in the oil and gas industry. I'm supporting, as I was saying, I'm supporting our team here. Hi, Dizendo. I hope you can hear me well. Very happy to be with you. So just a few words about Microsoft mission. Well, you all know that our mission is to empower every person and every organization on the planet to achieve more. This is what drives us. And that's very important to keep this in mind when talking about Microsoft. I also wanted you to know that these are when we're thinking about energy at Microsoft, these are the three main buckets of challenges that we can see from our window. Well, the first point is about security. Not only security of supply, but also cybersecurity and making sure that the infrastructure, the energy infrastructure, are not at the mercy of hackers or malwares. So we believe that that's something key. Hackers are doing a better and better job every day, and the security must be at the top of our priorities when thinking about energy. Second, access. There's still in the world a very large number of people who do not have access to electricity. And there's an estimation from the World Bank about that this is about, we're talking about 1 billion people in the world. But I just want also to highlight that the cost of energy in some cases is pushing some people out of the market or is driving them to reduce their usage of energy to the bare minimum, and this is sometimes really, really low. And this is true as well, I would say, in European countries, or in France, for instance, where I'm based. We have some people who cannot afford to pay the power bill, so they have to refrain and restrict their usage of power. So equity, access, these are key things. And the third buckets of challenges we're seeing in the world today, that's obviously about energy transition. There's a huge shift going on. We can see the effects of the climate change in our daily lives everywhere in the world. And governments, companies, everybody is moving toward in the same direction, trying to reduce our CO2 emissions to avoid a larger increase in the world temperature. Just one key point also to add. That's this. Brad Smith is the General Secretary of Microsoft, and that's key. What he says here is that we have the conviction that we want to work with every energy company in the world to help them to transform. You know, there's some debate in some part of the world, and with some other let's say partners of ours or similar companies that do not want to work with oil companies because of the carbon emissions that are related to the industry. That's not the way we work. We want to work with everybody. We believe that every energy company is a part of the solution, and every company has the willingness to address the world energy challenges. Then moving to the way we support the energy industry, and we do that with those four different streams. Then first of all, we've got what we're calling the industry solutions. This is what all the use cases and the solutions that are built by us or by our partners to address the challenges of the energy companies. Then we've got everything related to our partner ecosystem. I could hear in the presentations today that there are several of our partners during the in the different sessions and the different rooms today. I could hear somebody from Cognite and ASLB talking this morning. That was absolutely fascinating. Then we've got some technology that are dedicated to oil and gas, and we've got some. Eventually, I want to talk about the alliances that we've built with the main energy companies in the world. Just for you to know, so we've got this. We're splitting the use cases and the support and the solutions we're giving to our clients with these 4 buckets. So everything related to the workforce, and that takes into account operators on the field, and everything related to the mobile tools that they may use to do their job better. Everything. Then the second bucket is around operations. Then third, about everything related to the acceleration of your net zero conversion. So everything related to the renewables projects you may be working on. And last, about innovation, we believe that the energy transition is giving the opportunity to create new services and new products for our clients. We do that with, as you can see, those names, those logos. We do that with every company in the world. We do that with our technologies. To name a few, Azure, Microsoft 365, well, you know them. But the most important thing on that slide is those 3 dots you can read at the bottom. We want to do that with trust. We believe that this is the main asset that Microsoft has, and we're working on that on a daily basis. That is the trust you have for our company, the way we behave, and the product we are marketing. Then there's the question of scale. We offer the world the opportunity to scale your innovations in a safe way all over the world with our energy, with our data center infrastructure. And last, we want to be top. We are one of the leading companies in terms of cybersecurity. We offer that's a $20 billion business for Microsoft cybersecurity, and we believe that this is key to achieve your business goals. Partners, well, you've seen a few again today in the and you'll see some of our partners today during the different sessions. Well, that's very important for us. We've got something like I think 70 or 80% of our business worldwide is done with partners. So we're proud of that, and we're very happy to work in a close relationship with those powerful companies to address your very specific needs. That's the way we work. We call that the triple crown effect. When there is a powerful company like SLB supporting Chevron, our customer, and with Microsoft working the 3 of us to address a business challenge. Now let me give you a few words about Azure Data Manager for Energy. Let me put it this way. We've got the conviction that energy companies of tomorrow, they will leverage, if they want to leverage the most advanced technologies, they need to split the applications from the data. And in that case, we're talking about subsurface data, the open source protocol OSDU that can be hosted on Microsoft Cloud, and where all the application system can work on to deliver the results you need. And we believe that this is absolutely key to have this kind of infrastructure, because that's the way for you to secure your data in a safe way, and on top of that, to use and test and scale all the great applications that are built by our partners. And this is a key element in today in energy infrastructure, to have this kind of opportunity. We believe that this could be a way to absolutely change the way exploration and production is managed today for your subsurface projects. that will not end to that. So today, on Azure Data Manager for Energy, you can leverage the power of the cloud on the OSDU data. But we want to go beyond that. We want to work as well on carbon, and we want also work on carbon data, and we also want to work on grid and everything related to the to power and utilities businesses. So the story doesn't end here. We want to, both for carbon and for power, we want to have the same kind of architecture, again, where data will be split from the applications, and data will be hosted in a safe, compliant architecture such as Microsoft Azure. That's something we're working on. I was talking about carbon. We proud ourselves to be a leading partner of Northern Light. So together with Shell and Total Energy and the Norwegian government and Equinor, obviously. So this is really something big that is happening now. We are experimenting new technologies, and we. And a few thoughts about Azure Data Manager for Energy. You have to know that this product, Azure Data Manager for Energy, is available today. I mean, we call that general availability. So this is a product that you can use today in your operations. Very happy to be with you today. Let me know if you've got any questions.
Thank you, Mr. Mark, for your wonderful presentation. And it was very nice to see your ideas, these ideas that Microsoft is spreading. We don't have any question here, so I think we can finish because we finished all the online presentations for today. Thank you very much again, Mr. Mark.
Have a good day all, and bon appétit.
Maybe next time you can be here.
Thank you so much.
In person.
With great pleasure.
Okay, thank you.
Thank you so much.
Escreve-se no chat. Obrigada a todos que estiveram a acompanhar-nos online. Nós vamos encerrar por agora, porque as apresentações que nós tínhamos online terminaram. Se puderem ir para a sala principal, agora estamos no intervalo do almoço, mas na sala principal, depois do almoço, nós iremos continuar a fazer apresentações, vamos continuar a ter apresentações, vamos continuar a ver temas muito interessantes, por isso agradecemos a participação dos colegas e muito obrigada.
venho falar, meu irmão, de um tempo sem guerra, um tempo de paz, sem ódio nos olhos, sem armas na mão, povo na rua qualquer, seja a cor, esteja a sorrir, a completa união, caminho ao Cunene, mostradas Angola, Angola no coração, caminho ao Cunene, mostradas Angola, Angola no coração.
Eu venho falar, meu irmão, das pedras, dos rios, dos peixes do mar, da força da terra que faz renascer a nova certeza, Angola mudar, festeja a sorrir, a completa união,
Caminho ao Cunene, mostradas Angola, Angola no coração. Caminho ao Cunene, mostradas Angola, Angola no coração.
eu venho falar, meu irmão, do tempo sem guerra, do tempo de paz, sem ódio nos olhos, sem armas na mão, o povo na rua, esse já foi, eu estou rindo, a completa
Caminho ao Cunene, mostradas Angola, Angola no coração. 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 Preparar um carro de praça, ansioso em ver meu amor. Chofer de praça então reclamou quando me disse que meu bem morava no subúrbio. Ei,
tempo chuvoso no subúrbio não vou, pois sou chofer de praça e não parquei. Então implorei, peço ao senhor chofer, leve-me então por favor favor, ela não tem culpa de morar no subúrbio. Enquanto a chuva é obra da natureza, enquanto a chuva é obra da natureza. É um chofé dominado por mim, da borracha puxou, atravessando lagoa. Quando eu olhei pro relógio, ele pediu que colocasse o acelerador ao tapete. Então sofrendo, respondeu: você quer ver seu amor atravessar a lagoa a pé? Não vou partir, só porque você quer a chuva. Então chofé trombudo respondeu: se você quer ver seu amor atravessar a lagoa a pé, não vou partir o meu popô, não vou partir não, só porque você quer dar show.
Zanje, zanje, zanje,
Salapinga,
zanje, namutula mwene,
salapinga,
zanje, kakina kayuke,
salapinga,
zanje, mutaji ya mala,
salapinga, 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 salapinga,
zanje, zanje, zanje,
salapinga,
zanje, namutula mwene,
salapinga,
zanje, kakina kayuke,
salapinga,
zanje, mutaji ya mala,
salapinga, 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 salapinga. swagana, kudifuta. No, 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 no. Omwana ni utwa, shindolo shingi fula. No, no, kipanga kegeni mukolonge. Yeah. Kukushishima kwa mibo, wawe mwagole. Kukushishima kwa mibo, wawe mwagole. Kukushishima kwa mibo, wawe mwagole. Zaje, Salambinga, Zaje, Namutula Mwete, Salambinga, Zaje, Katina Kayake, Salambinga, Zaje, Salambinga, Zaje, Mukaji Yamala, Salambinga, Salambinga, Salambinga. Salambinga, Salambinga, Zaje, Namutula Mwene, Salambinga, Zaje, Kakina Kayuke, Salambinga, Zaje, Salambinga, 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 Nyanya kuzwakana, kutufuta. Yeah. Omwana ni utwa, shindolo shingi fula. Nana kipanga kebyeni mukangonge. Yeah. No. Kukushishima kwa mibo, wawe mwagole. Kukushishima kwa mibo, wawe mwagole.
Se wangande, wanga wami. Ngidekela. Se wangande, wanga wami. Ngidekela samani. Watu dilla, mjibe. Watu dilla, mjibe. Watu dilla, mjibe. Wa, dilla, waseka. Mushinda, oh mushinda, oh mushinda. Mushinda, oh mushinda, oh mushinda. Se wangambe, wanga wami, yeah. Ungibekewa Santana. Se wangambe, wanga wami, yeah. Ungibekewa Santana. Wato de lá, Jimujide. Wato de lá, Jimujide. Wato de lá, Jimujide. Uajibilani Kasoga. Oshimba. Se wangambe wangawani, yeah. Ugibekewa Santana. Se wangambe wangawani, yeah. Ugibekewa Santana. Wato de lá, Wato de lá, Wato de lá, Uajibilani Kasoga. Hey, mama. Hey, sinto-me orgulhosa de ser africana. Meus antepassados todos nasceram aqui. Filha legítima do mundo rainha, minha África, oiê, oiê. Sinto-me orgulhosa de ser africana. Meus antepassados todos nasceram aqui. Filha legítima do mundo rainha, minha África, oiê, oiê. Angola, oiê, oiê, oiê. Moçambique, oiê, oiê, oiê. Guiné-Bissau, oiê, oiê, oiê. Cabo Verde, oiê, oiê, oiê. São Tomé, oiê, oiê, oiê. Angola, oiê, oiê, oiê. Sinto-me orgulhosa de ser africana. Meus antepassados todos nasceram aqui. Filha legítima do mundo rainha, minha África, oiê, oiê. Sinto-me orgulhosa de ser africana. Meus antepassados todos nasceram aqui. Filha legítima do mundo rainha, minha África, oiê, oiê. Namíbia, oiê, oiê, oiê. Congo, Congo, oiê, Oh yeah, oh yeah. Oh yeah, oh yeah. Oh yeah, oh yeah. Oh yeah, oh yeah.
Quando a subir, daqui a pouco estou triste. Valeu, Cota. Grande trabalho. Deus tem. Olha assim. Mumpioso amém. Mumpioso amém. Mumpioso amém. Mona milanque, sequendas amém. Mumpioso amém. Mumpioso amém. Mumpioso amém. Mona milanque, sequendas amém. Mumpioso amém. Mumpioso amém. Mumpioso amém. Yeah. Assobio meu, assobio meu, assobio meu, é pra esquecer meus pensamentos. Assobio meu, assobio meu, assobio meu, assobio meu, é pra esquecer meus pensamentos. Yeah. Assobio meu, é pra esquecer tristeza. Vai, Nino Jazz. Isso agora com tudo. Nada de anunciar. Vamos. Olivia. Yeah. Mumpioso amém. Mumpioso amém. Mumpioso amém. Mona milanque, indizame. Mumpioso amém. Mumpioso amém. Mumpioso amém. Mona milanque, indizame. Induzame. Suja, marabu. So that's what I'm talking about. Just go fast.
Olha, uma vez um boba. Kandala meu kitarikenu. Kandala kishika maboba nangita meu nisoso. Umweyo ni utopia. Nongile yoso mshima. Endeleno makamakudia. Zambi mukibela kietu watu jindu shangana. Kuteno makongo kwa lupale. Sanga kizua mwagiwane. Oswa dimuna mwene makarumba. Ujimbe kunujipange jami jama. Para kuwabeza mshima. Ngeza muito mila boga. Nandala meu kitarikenu. Nandala kishika maboba nangita meu nisoso. Omui utopia. Lungile lyoso mshima. Kandeleno makamakudia. Zambi mukibela kietu watu jindi kiangana. Kuteno makongo kwa nupale. Sanga kizua mwagiwane. Oswa dimuna mwene makamba. Ujimbe kunujipange jambi jama.
Eu não aguento mais com essa mulher. É a garina dos meus olhos café. É a preta dos meus olhos café. É a garina dos meus olhos café. É jamaicana, dominicana, americana, portuguesa. Se eu puder entrar aquela angolana, preta alta, beleza africana. Eu não aguento mais com essa mulher. É a garina dos meus olhos café. É a preta dos meus olhos café. É a garina dos meus olhos café. É jamaicana, dominicana, americana, portuguesa. Se puder entrar aquela angolana, preta alta, beleza africana. Quando ela vai à praia, morenão, você aí que começa a cenar. Todo mundo olhando para a preta, ela com uma tanga. Com os seus seios de mangas, passa-te ciúmes por ela. Afasta ciúmes na areia onde se deita, porque quem vai à água vê o corpo dela, essa miúda de funcionária. Eu não aguento mais com essa mulher. É a garina dos meus olhos café. É a preta dos meus olhos café. É a garina dos meus olhos café. É jamaicana, dominicana, americana, portuguesa. Só pode ser então aquela mulata preta alta, beleza africana. Eu não aguento mais com essa mulher. É a galinha dos meus olhos café. É a preta dos meus olhos café. É a galinha dos meus olhos café. É jamaicana, dominicana, americana, portuguesa. Só pode ser então aquela angolana preta alta, beleza africana. Não. Quando ela vai à praia morena, fico todo emocionado. Fico todo emocionado. A pergunta é quem está olhando já. Mas você só diga uma coisa, essa miúda é muito tarada. Ela tem um andar impressionante. Beautiful. Eu não aguento mais com essa mulher. É a galinha dos meus olhos café. É a preta dos meus olhos café. É a galinha dos meus olhos café. É jamaicana, dominicana, americana, portuguesa. Só pode ser então aquela angolana preta alta, beleza africana. Eu não aguento mais com essa mulher. É a galinha dos meus olhos café. É a preta dos meus olhos café. É a galinha dos meus olhos café. É jamaicana, dominicana, americana, portuguesa. Só pode ser então aquela angolana preta alta, beleza africana.
Manhã de domingo, sol lavado forte no telhado, levanto uma nuvem de pó. Perguntam os mais velhos o que é isso. Alguém responde, eu vou a descer a marginal atrás de dar. De alegria, por causa do sol bem forte, nos leva até aí. Os menditos também vão, quem agarra caroneiro feliz, mas para onde vão é que ninguém diz. Todos mal trajados, todos despenteados, todos cacimbados, todos bem cansados, todos mal trajados, todos despenteados, todos cacimbados, mas com a feliz o mesmo não diz. Do calcanhar escaldado, do calção cansado, sordo todos os dias. Tá vivendo um bom passeio, tô o dono veio, desenho também. Estamos no domingo, dia de alegria, dia de paz e de fim de nostalgia, dia de areia, que não é bicha, dia de sol, que não é esquema, dia do mar, que não é processo para nos lavar. Ao lado do processo já vem do mar,
Tem outra parte, vem desgraçado. Até próximo domingo já vem tunar. Vem cacimbar, bem descansados. Até o próximo domingo. Ai, ai, ai. Ai, ai, ai. Ai, ai. Boa.
patita ngibane yanami mane patita ngibane yanami emengi kwena kaswaswa nibeka wamingo emengi kwena kaswaswa nibeka wamingo emengi banze anami emengi banze anami emengi banze anami emengi banze anami tunde kitwena tukala mingwitano tunde kitwena tukala mingwitano mama emengi banza nami emengi banza nami emengi banza nami emengi banza nami patita patite eyo patita eyo ngongozana patita patite banza patita eyo ngongozana Mane patita ngibane anami Mane patita ngibane anami Emengi kwena kaswaswa nibeka wamingo Emengi kwena kaswaswa nibeka wamingo Emengi banza nami emengi banza nami emengi banza nami emengi banza nami patita patite banza patita eongongo jami patita patite eyo patita eongongo jami patita patita patite banza patita eongongo jami patita patita patite banza patita eongongo jami
Quem são vocês pra me calar? Vocês andavam a duvidar, agora vão acreditar. Com cima de mais forte, sempre que dá e acreditar. Glória não pode dizer, essa vida não só é tudo. Deixa o todo ficou confuso, seu cantar voltou a dar. DJ, evita problema, stop, para. Bora, bora, então rolou, a dança rolou, mas todo mundo é bom. E depois eu gostou, quando o bonequinho então rolou, a dança colou, mas todo mundo é bom. E depois eu gostou, é um beijinho, olha já, é um beijinho, olha já, é um beijinho, olha já, é um beijinho. Nessa dança que fui amado, no Natal e Carnaval. Nessa dança que fui amado, no Natal e Carnaval. Que não sai daqui não vai, que não sai daqui não vai. Ai, felicidade, todos nós queremos dar. Felicidade, todos nós sentimos dar. Felicidade, todos nós queremos dar. Felicidade, todos nós conseguimos, porque estamos sempre a sofrer, sempre a sofrer, estamos sempre a sofrer, sempre a sofrer. Ficam tendo tendência, pensam que são muito diferentes, corrigem dúvidas a dúvida. Se tá criando, batam palmitas, você acha que é muito fino. Vocês caíram na armadilha pra fazer bala como pastilha, pra tirar essas pastilhas. Corrigem dúvida mais perfeita, duvidam que são duvidas. Então você sabe calar, você já tava duvidando, quando ela não acreditar. Com os que mais forte, sempre que dá e acreditar, agora e hoje pode dizer, essa dupla missão é tudo. Ai, felicidade, todos nós queremos dar. Felicidade, todos nós sentimos dar. Felicidade, todos nós queremos dar. Felicidade, todos nós sentimos. Felicidade, ai, felicidade, todos nós sentimos, porque estamos sempre a subir, porque estamos sempre a subir, porque estamos sempre a subir, porque estamos sempre a subir. Ai, felicidade.
Do patrão importante. Lá da escola, perguntava nunca pra você qual era a razão daquela confusão. agir, mergulhada em seus pensamentos. Ela sabia, mas ela não dizia qual era a razão. É menina, a política, a política. É menino, não fala política. A política. Tempo passou, que a velha chica, sou mais velha que tu. Ela comente só uma culpada dentro de ti. Menino, não fala política. Fala política. Não fala política. Menino, não fala política. O rosto daquela senhora que ninguém vê, já não vê mais o sofrimento, já posso morrer, já vi agora defender. Já posso morrer, já vi agora defender. Posso morrer, vi agora.
Thank
que me ama. Depois desse acabou a cama, arrasta meu nome na lama. Depois desse acabou a cama, arrasta meu nome na lama. Sai daqui, ô parceiro, não suporto chulé. Sai daqui, ô parceiro, não suporto chulé. Ainda está na porta tua dor, arrasta mais uma na puxa. Está na porta tua dor, agora arrasta mais uma na puxa. Mamá, não se meta solar, esse homem da seria estúpida. Mamá, não se meta solar, esse homem da seria estúpida. Ele não procura emprego, só mal um bom posto. Ele não procura emprego, porque sou mal um bom posto. Mas ele só quer dar me ver, que é mulher. Mas ele só quer dar me ver, sai, ai, 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 sai, fazer, mistério, mulher, sai, ai, 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 sai, fazer, mistério, mulher, só quer dar me ver,
tempo sem terra, muita possibilidade de crescer e encontrada. Hoje eu brilho, amanhã brilha como o sol. Aqui pode alcançar o céu, agora eu acredito. Agora eu acredito. Agora eu acredito. Agora eu acredito. Das canções do nosso povo, o nosso fascinar. Este é o país do tudo perto. Uma terra tão fértil como os sonhos. Dos rios às montanhas, do deserto às praias da nossa costa. Alcança o céu, agora eu acredito.
Ah
aquele gado da ceia, o bicho pra casa da boca, rosa, e o povo fica maluco, vai lá, com feitiço que entendeu a nossa vida, rosa, vai lá, esse povo mais bonito da nossa manhã, rosa, vai lá, não fica, rosa, vai lá, quando baila tu ficas muito mais bonita, rosa, vai lá. Rosa bailar, Rosa bailar, bailar, Rosa bailar, bailar, Rosa bailar. Apreciadores de vidas santas, vendo todas bailando, celebrando como es que hacían antes. Antes de que los estrellos substituir para Pernambuco, roda cheia e o povo fica muito maluco. Esse povo fica nessa batalha, baila, baila, cosita. Ai, quando bailas tu ficas mais bonita, rosa bailar. Ai, 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 rosa bailar. Rosa bailar, bailar, rosa bailar, bailar, bailar. Rosa bailar, rosa, rosa bailar, 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 rosa bailar, rosita bailar, bailar. Rosa bailar, Rosita, Rosa bailar, bailar, Rosa bailar.
Mama no dila misala, we kubeka zelaye. Mama udila misala, we kubeka zelaye. Mama kwele kosa pewe, ambogo la pekita. Mama kwele kosa pewe, ambogo la pekita. Wanda lo pekita. Wanda lo pekita. Wamuto lo pekita.
Inda como tú
Não é um merengue do pânico, mas o merengue da nariz é quase igual a tu pai. Fica tudo encambulado, vem dançar o merengue. Se estás na druga ou na banda, completizões aquelas, isso não interessa. De mini saia ou vestido, de fato ou calção, isso não interessa. Venga a bailar el merengue de la vida. Venga a bailar el merengue de la vida. 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 Não é um merengue do país, mas o merengue da Nani é quase igual a tu pai. Fica tudo encambulado com dançado. Estás na fuga ou na banda, completizões aquelas, isso não interessa. De mini saia ou vestido, de fato ou calção, isso não interessa. Largo no preto e o feijão, a capivara e a ginginga vem das.